So I am Nicolas Noriega. I am the Director of Data Science for Prompta Consulting Group. We are currently, obviously, working on machine learning models and obviously natural language processing. We are focusing on a specific parts of the business when it comes to modeling text data. And obviously, one of them is topic modeling. Besides that, we obviously have a broad strategy that is bringing us to these kind of things. I am gonna jump in, and I think I don't know how much time we have, Aidan, but please let me know. So just to recap about what I'm putting all these slides together, how our strategy basically falls into place. And here are the 4 pillars of AI applications. I think probably most of us that have been in the machine learning community are pretty much about or aware about these 4 pillars. And one of the reasons why I bring them on is because sometimes we kind of forget. And the reason is that we need a solid strategy, and that's the success of any business, whether it is AI, whether it's just simple IT, or any other vertical. So obviously we need the business, we need the market actually to develop that business. We need the algorithms, we need the data, and obviously we need the computing capacity to bring all this to life. And when it comes to business, for example, NLP has been actually quite enriched from the different sectors that actually have been utilizing, whether it's healthcare, whether it is wellness, whether it's travel, whether it is, for example, online retailing and other kinds of things. So that's extremely important as to how we can actually bring all these verticals together. And I think NLP has been one of the most enriching areas of AI to actually leverage and utilize all these 4 pillars. Just a quick reminder of what is the algorithm ecosystem and why I keep bringing them up. I think, for example, in terms of big giants, tech companies, obviously they have access, and obviously they have collected over the years amounts of terabytes of data who can actually test on a lot of things. And that's obviously the case of deep learning. Obviously smaller companies, especially startups, for example, utilize pre-trained models. But putting all this together is actually because the strategy is that when we utilize a successful algorithm, when we utilize successful elements, for example, of data visualization and all that, we can actually identify patterns and obviously make very effective predictions. Obviously, I'm not gonna go through all of them, but obviously high dimensional data, especially principal coordinates analysis, makes a big sense or make a big sense for NLP. And the reason is that remember that whenever we have a data set, and obviously with lots of data, it's just mainly data that we need to put into coordinates. For NLP and for especially for topic modeling, there are 2 principal algorithms that obviously we use over and over, and I've seen a lot of academic programs bring them actually a lot to not only assignments but also projects or consulting. And it's the expectation, the EM algorithm, the expectation maximization, and the latent Dirichlet allocation. Obviously, these models actually work extremely well. That's my latest understanding based on current research, especially with bidirectional LSTM. and also bidirectional GRU. But when we talk about topics, we basically and I see this when I deal with clients all the time. No matter the industry, is that they still have a hard time or not a clear understanding about how NLP works, and how, for example, some tools, especially when it comes to social media, should be utilized and all that. So intuitively, we can understand it. And just remember, for example, the previous slide when I talked about one of the pillars of successful AI applications is that to have that computing capacity. Because when we understand things, we can understand the principal idea that is discussed in text data, or, for example, the discussion in conversation among the individuals. And obviously, we have different granularities when it comes to understanding what is a topic or any sentence in natural language processing. But imagine going through a lot of data. Can be a paragraph, can be a sentence, can be a news article, can be the library section of any specific topic for discussion, can be a lot. So how do we utilize this, right? When we talk about topics and when we utilize this kind of tools, we can actually find them in a variety of ways. Can be, for example, on a product review, and can actually how that product review can inform and redesign a product when customers give a specific feedback. How, for example, employees post reviews on specific employers on Glassdoor, and how, or on how, for example, a response to a survey on an open text survey actually can be collected. So this is just an example on how for example, this can be utilized and how companies are currently using it. When it comes to natural language processing, I'm going to talk specific algorithms that we can utilize for specific problems, and mostly because these are the most utilized in the industry. And obviously, there are tweaks that we can do. For example, when we try to model our text data. One of them is the probability latent semantic analysis. This, for example, utilizes the expectation maximization. Some areas of this expectation maximization works extremely well as an unsupervised algorithm. And obviously, the beauty of this is that it doesn't require human intervention. Right. So when we have, for example, a problem that can be easily understood, quickly to analyze, or something like that, definitely PLSA it's an algorithm to use for. Doesn't compute the probabilities of an unseen document. So obviously, which is extremely important for machine learning, because at the time when we productionize any ML model utilizing PLSA, that is not going to work very well with unseen data. So we obviously keep an eye on that. The expectation maximization algorithm that's actually quite utilized in the industry. It's a tailor-based approach for topic modeling, and because of the mixture of multinomial distributions. As I said, is quite widely utilized in practice. And there are key assumptions that actually, when we work with this specific algorithm, there are two assumptions to make. Obviously, it's measured through counts, and obviously the order doesn't matter when it comes to what position, or when the word is, how position is the word, that basically it is irrelevant. And one of the most important algorithms that is out there and is still very, very utilized is the LDA. Obviously, here I just put an example as to how it is computed, what actually takes into account, takes parts of the PLSA, and obviously it takes parts of the EM, of the maximization algorithm. And basically the last part is that actually the contribution of the LDA to topic modeling. It explains model data extremely well. It uses a maximum a posteriori or an MAP, and also uses the maximum likelihood estimate to compute the unknown parameters. The advantages of this algorithm is that utilizes prior knowledge, and as we know, or whomever has been in the ML community long enough, priors are extremely important, right? When we try to generalize this model on a broader scope. And two of the things that actually this algorithm is very enriching is that it covers all the possible word distribution for topic characterization. But the most important thing is that all possible coverage distribution of topics in a document actually is covered from the LDA point of view. It's based on the theorem, on the Bayes theorem. So that's one of the most important things that this algorithm is so utilized. When it comes to business applications, where obviously it is highly used in healthcare. For example, the previous topic was about insurance. So when it comes, for example, to insurance data, NLPs definitely can be benefit from a lot of data collected, especially when it comes about claims data, healthcare policy, patient diagnosis, product development and forecasting, obviously, as I mentioned that before. And one of the key things that actually NLP can contribute a lot is to human resources and change management. When companies go through digital transformation, this is actually the type of algorithms that actually we use a lot to inform leaders as to how not only their workforce is doing, but also how the workplace is doing overall. So listening in this way, it actually matters. And mostly when it comes to large volume of data, obviously this allows a very enriching evaluation of the whole business. When it comes to the process flow, the way we put the data together, that's extremely important, because that is actually how these algorithms make sense. The lexical analysis, which puts every single words into perspective. The semantic analysis, how, for example, we map a whole sentence and all the data that actually we collect, known phrases to entities, verb phrases to relations, and obviously the stemming or lemmatization as to how we put all this in context. At the FIDF, obviously, is extremely important for a more rigorous analysis. And why do I bring all this together? Because at the time to put it into practice, that is actually when the problem-solving approach comes to actually design good NLP applications. How do we do so at Prompta? For example, in the old ways, when companies went through change or transformations or the alike, consultants used to interview just the top level executives. And obviously, executives have a very, very, very different understanding as to how really what's going on below them in terms of the decision making change. There is a very, very, very large failure rate when it comes to change management projects, especially also with digital transformations. I think that the rate is in the 80 or 90%, something like that. So when I was interviewing and when we were actually going through the development part of our AI platform, I was interviewing consultants, and I remember that one of them basically told me that when he was working with an executive, this executive actually mentioned to this consultant, one of the top consultants in the world, we implemented a change project quarters ago, last year, something like that, and it failed. How do you assure me that actually the one that it's coming, it's actually gonna work out? Can you assure me that actually it's gonna be successful? So basically the response, and I'm a little bit paraphrasing, has been a little bit of a time at the time I interviewed this consultant, is that we need to interview more people. Executives have a different perspective as to the rest of the employees. The rest of the employees are in the battlefield of the day-to-day business. And when it comes to problems and analysis, technology adoption, basically they have a different understanding, and different understanding not only about expectations, but only about how the workplace actually works. So this is just an example as to when I meant to interview more people, is actually we surveyed the entire workplace, because that's the only way we are going to have a very, very clear understanding as to what's going on. This, for example, is another example as to when we implement one of these algorithms, especially with taking into account the term frequency inverse document frequency index, obviously provides a slightly different perspective, and obviously that can enrich the data or the whole application overall. And how do we do that, and how do we actually apply it to business? When we're building our tool, and obviously the results that we provide is that we compute the sentiment score for the entire topic. And that's a very important process as to how we put all this into perspective, how we take into account the latent semantic analysis, how we actually model syntactic semantic process, so we can actually make sense of the scores that we are actually computing, because that's extremely important to basically provide a good understanding on the business. And how do we do classification? When we actually put this kind of a perspective and putting in a measure of similarities, and that's one of the reasons why I brought the principal component analysis into perspective, because it actually allows us to classify this data in a more perspective way. When we do this kind of classification, that's basically, we are telling the client that when you provide this lack of opportunities, when you provide this kind of, you have these kinds of problems in your business. And that actually means money, because you are not only at risk of losing employees, but basically it is going to be in detriment of the whole company in as to how it makes money, and not only in terms of profitability, but also in terms of culture. And this is actually my last slide, because when we put this into perspective, is that NLP can actually help us to visualize a whole company, and basically to predict not only future behavior, but future probability. When it comes, for example, when we talk to vision, when we talk about, for example, to success criteria, when we talk about to leadership capability and culture, and obviously operations, when we put this into perspective, we can actually make a very, very, very good prediction as to how your company it's gonna make actually the next quarter.
What kind of encoding strategies are used for transforming text to values for LDA or other analysis?
The way, for example, we pre-process the data, that's actually the most important thing for us. Because basically you can deploy any algorithm, right? You can actually, when we code an algorithm from scratch, right, we can actually visualize the components that are behind it. And we can use libraries, we can use any kind of thing. But also, especially, and I believe for any machine learning model, is still the feature engineering, the data preprocessing is quite important. With deep learning is a different story, because for deep learning, we don't need data or feature engineering a lot, right? Basically, almost none. But if we are not implementing, for example, deep learning models, we still need to manipulate and pre-process the data in an intelligently way. In terms to answer your question, in terms of how we encode data, how we for a successful algorithm development, I think and especially for NLP, I think is making sense of the syntactics and lexical analysis that is behind. That is one of the reasons why I put it in the slides. And I know it was gonna be a little bit technical. I didn't know how in depth I should go, but it is quite important. These kinds of encodings and preprocessing and all that. And especially, actually, your question is quite interesting, because when it comes to computing the sentiment scores, and when we compute, for example, at least for our platform, we just don't compute positive or negative. No, we have a scale to develop that, right? So we can actually make effective predictions. And when we compute that, we need to make sense of every single sentence that is actually computed, of every single document. Every single document for us, it will be like every single response on a survey. And obviously, sometimes we leave it in the number of characters that it's up to the respondent, because what we want to collect is data. And we want, for example, in this case, let employees type and type by type, because that is the only way how we are going to find out about the true feelings and the true opinion about the areas that actually they work in.
Some topic modeling techniques require a manual analysis to properly understand and define the produced topics, which I assume is time-consuming and hard to scale. Have you faced this kind of problem and found a solution for it? How do you deal with the need for human intervention required by some topic modeling techniques?
Yes, you are absolutely right. Actually, NLP is one of the few areas of machine learning or data science overall that still require human intervention. And so we try to make sense of the data. We actually don't go behind scenes to manipulate or because we can use pre-trained models for that. So we actually make sure that the algorithms are behaving as expected or the way we expect. And one of the algorithms that actually do not require as much as human intervention is PLSA, but it has its flaws, right? So, for example, when it comes for us to make classification predictions, and we don't want, for example, to do a lot of human intervention, PLSA is definitely the algorithm to work for, right? Remember, data visualization in this regard, because who will actually imagine that through NLP, we can actually forecast the next quarter of a company, right? That's a difficult task to do. We usually I have a finance background, so we usually relied on financial data, quarterly financial statements, and so forth, right? But when actually executives, when leaders were, well, we were supposed to do this, and they didn't really care too much about employees' reaction to that. So the surprises were actually coming their way, right? So who will actually think that NLP will actually be extremely helpful to forecast actually their business quarters? So when we do this kind of classification and we don't want a lot of human interaction, I will suggest work with PLSA. It's a stable. Obviously, if you are going to productionize that model, it doesn't work very well to unseen data, right? But when it's just about the visualization or just a quick classification that requires immediate attention, PLSA is actually an algorithm to work with. If you work with other algorithms like expectation maximization or LDA, try to code it from scratch. Try to code those algorithms from scratch and see if you can make some tweaks and do a lot of testing and see how the algorithm behaves, and hopefully to the point that doesn't require as much human intervention, and use pre-trained models so you can actually get a good result.